Hello and welcome back to the video series where we are providing the high-level overview of the textbook Blueprint Reading Construction Drawing for the Building Trades. And this video is about chapter 11, and that is Building Codes and Barrier-Free Design. So the purpose of the building codes is to govern the construction of public buildings, commercial buildings, and places of residence, and to regulate construction and thereby provide occupants with a safe and healthy environment. And for the architects, it's important to provide health, safety, and welfare of the public. Building codes are an imperative part of the design and construction process. They define minimum standards for safety and comfort that must be met in new construction and major renovations. Prior to having obtained a building permit to construct a commercial property, the developer is required to produce design plans that conform to the building codes in effect at the time. Existing properties are not normally required to conform to newer code requirements unless major renovations are performed. When older properties are to be updated, local regulations dictate the conditions when compliance with newer codes is required. Typically, when interior renovations include reconstruction of 25 to 50% of a floor, um, then the local regulations are needed, and existing life safety code is enforced to follow. It is therefore important to determine the functional obsolescence of all major life safety elements. This is particularly relevant to office buildings and hotels, where interior renovations and reconfigurations are periodically performed. Building codes are essentially local laws, and each municipality, county, or district enforces its own set of regulations. A strong and sustained movement has been underway for many years to unify the various codes around the nation in response to the buildings industry continuous request for a single unified building regulatory system. The majority of states have already moved in that direction, and three main code organizations have come together to form the International Code Council, or ICC, whose cardinal mission is to unify the code system into a single set of comprehensive building codes that can be used anywhere in the United States. So, as far as the building codes today, one of the most confusing aspects of American codes and standards is that, unlike, for example, Europe or Canada or many other parts of the world, there is a complete absence of uniformity between federal agencies, states, counties, and municipalities. Although in recent years there have been major efforts to unify codes on the national level. When dealing with counties and municipalities, we are confronted with other issues. For example, cities such as Houston have large oil refineries to create certain hazards that cities such as Chicago and New York require special codes and standards that relate to high-rise buildings and population density. The state of California has also decided against using the IBC codes and elected to configure using the 1997 Uniform Building Code as the basis for the 2001 edition of the California Standards Code. On the other hand, a town that lies in the path of hurricanes may require special storm prediction standards. It's no surprise, therefore, that some codes have evolved through modifications necessitated by particular geographic and population needs. And for example, in Florida, We have wind design criteria and other regulations that we need to follow when we submit the documentation for permitting. The IBC establishes minimum standards for the design and construction of building systems. It addresses issues such as use and occupancy, entry and exit during emergencies, engineering practices, and construction technology. So let's talk a little bit about the ICC, or International Code Council. So ICC was established in 1994 as a nonprofit organization dedicated to developing a single set of comprehensive and coordinated national model construction codes. The founders of the ICC are building officials and code administrators. Um, so that's BOCA, Building Officials and Code Administrators International, Inc. Then ICBO, or International Conference of Building Officials, and SBCCI, or Southern Building Code Congress International, Inc. Although regional code development has been effective and responsive to our country's needs, the demand arose for a single set of codes. The nation's three model code groups responded by creating the International Code Council, which combines the strength of the regional codes without regional limitations. ICC made great strides when, in the year of 2000, it published the International Building Code, or IBC, a single family of codes that is being adopted across the nation. It's hoped that as the IBC gains popularity, the existing regional and local model codes will be phased out. Today, an overwhelming majority, which is 97% of the cities, counties, and states that adopt building code and safety codes are using documents published by the ICC and its members. The IBC, like the predecessors, will be updated every 3 years and will gradually replace the existing model codes, BOCA, ICBO, and SBCCI, have agreed to merge their respective organizations into one model code group. This will allow a single approach to the proper interpretation, training, and other services for the international codes. The building officials and code administrators, or BOCA, model code was incorporated in 1938, and it's the oldest professional association of construction code officials in America. The Uniform Building Code, or UBC, is published by the International Conference of Building Officials, or ICBO, and that is mainly the west coast of the United States. Then the Standard Building Code, SBCCI, is used in much of the southeastern United States, and SBCCI joined with BOCA and ICBO in 1994. So let's talk about standard writing organizations and institutions. There are numerous organizations involved in writing and maintaining standards. The vast majority are developed by trade associations, government agencies, or standard writing organizations. Likewise, there is a long-standing relationship between construction codes and standards that address design, installation, testing, and materials related to the building industry. The pivotal role standards play in the building regulatory process is that they represent an extension of the code requirements and are therefore equally enforceable. So let's take a look at a few organizations. So the first one is the American National Standards Institute, or ANSI. and that approves standards as American national standards and provides information and access to the world's standards. It's also the official US representative to the world's leading standards bodies, including the International Organization for Standardization, and it provides and administers the only recognized system in the United States for establishing standards. The American Society of Heating, Refrigerating, and Air Conditioning Engineers, or ASHRAE, is an international organization whose role is to advance the arts and science of heating, ventilation, air conditioning, and refrigeration for the public's benefit. The next one is the American Society of Testing and Materials, or ASTM International, and that's one of the largest voluntary standards development organizations in the world, providing a global forum for the development and publication of voluntary consensus standards for materials, products, systems, and service having internationally recognized quality and applicability. National Standard System Network, or NSSN, has its primary mission to promulgate standards information to a broad constituency and serves as a one-stop information repository. National Fire Protection Association, or NFPA, is a worldwide leader in providing fire, electrical, and life safety information to the public. Underwriters Laboratory, or UL, maintains and operates laboratories around the world for the testing and examination of devices, systems, and materials to determine their properties to their relation to life, fire, casualty hazards, and crime prevention. So there are other agencies that regulate and produce building regulations that may impact the projects. So that is Access Board, previously named the Architectural and Transportation Barriers Compliance Board. Then the Department of Energy, or DOE, the Environmental Protection Agency, or EPA, the Federal Emergency Management Agency, or FEMA, the General Services Administration, or GSA, the Department of Housing and Urban Development, or HUD, the National Institute of Standards and Technology, and IST, Occupational Safety and Health Administration, or OSHA. So when we talk about the building code elements and applications, it's important to understand that most code requirements for fire and smoke protection are based on occupancy classifications. Occupancy refers to the type of use a building or interior space is to put to, such as a residence, office, school, or restaurant. Occupant load is a term used to specify the number of people that a building code assumes will occupy a given structure or portion thereof. Occupant load calculations are based on the assumption that certain categories of occupancy have greater densities of people than others, and that existing provisions should adequately reflect this. Load factors are depicted in either gross square feet or net square feet. Types of occupancy. So there are a few commonly used classification systems, and this is the one that we will be reviewing. So A is for assembly. With certain exceptions, it consists of structures, building or portions thereof, that are used for gathering for purposes such as civic, social, religious, recreation, consumption of food and drink, or waiting areas. And the examples would be a restaurant, or a bus terminal, or any other assembly buildings. Then B is for business, and that consists of office, professional, or service type transactions. So that can be your business center. E, educational, structures that are used for educational purposes by 6 or more persons over 2.5 years of age through the 12th grade. So schools will be definitely the educational occupancy. F is for factory and industrial, and that is the structures that are used for assembling, disassembling, fabricating, finishing, manufacturing, packaging, repairing, or processing operations not classified as Group H or Group S. And we are approaching Group H or hazardous. With noted exceptions, these are structures that are used for manufacturing, processing, generation, or storage of materials in quantities that are physical or health hazard. I, institutional, used for the care or supervision of people having physical limitations due to health or age, are harbored for medical treatment or other care or treatment in which occupants are detained for penal or correctional purposes where the liberty of the occupants are restricted. M, mercantile, buildings that are utilized for the display and sale of merchandise involving stocks of goods accessible to the public. R, residential, used for sleeping purposes not classified as Group I or per International Residential Code. So R1 is multi-unit transient, R2 multi-unit non-transient, R3 not classified otherwise, R4 residential care. S is for storage. So that is used for storage not classified as hazardous and consists of S1, which is moderate, and S2 as a low hazard storage. And the last one is utility. U is for utility and miscellaneous. And that consists of accessory and miscellaneous structures not classified in other occupancies. So classification by construction type. Construction type indicates the fire resistance of certain building elements such as fire and party walls, stair and elevator enclosures, exterior and interior bearing and non-bearing walls, columns, shaft enclosures, smoke barriers, floors, ceilings, and roofs. Fire ratings are based on the number of hours a building element will resist fire before it adversely affected by the flame, heat, or hot gases. All buildings are classified into one of 5 or 6 types of construction. So type 1 buildings are the most fire resistive, are typically contain structural members that are non-combustible. Type 1 buildings also have the highest fire rating, usually 2 to 4 hours. And on the opposite side, type 5 buildings have the lowest fire rating and are typical wood frame construction that we see in the single family residential. Adjuncts to building codes. So building codes typically have additional companion codes and standards that govern other aspects of construction, which, with the exception of the electrical codes, are usually published by the same group that publishes the model building codes. So model codes frequently use industry standards developed by trade associations, government agencies, and standard writing agencies such as ASTM or ANSI. Building codes reference these standards by name, number, the date of latest revision, and become law when a code is accepted by a jurisdiction. In addition, there may be local jurisdictions that maintain energy conservation codes, health and hospital codes, fabric flammability regulations, and codes that regulate construction and finishes. So, when we talk about test ratings and fire resistant materials and finishes, it is important to know that it is estimated that roughly 75% of all codes deal with fire and fire safety issues. And the primary aim of all the fire codes is to confine a fire to its area of origin, thus limiting its spread and preventing flashover. To facilitate this, all approved materials and construction assemblies referred to in building codes are assigned ratings based on standardized testing procedures. The rating of an assembly is ascertained by evaluating its performance during testing and by examining fire resistive properties. Means of egress. Exiting is one of the most critical requirements of building codes, and it comprises three main categories: exit access, exit, and exit discharge. And please refer to the book. There are a lot of good graphics and images that will be easier to understand. So, plumbing systems. Previously, major code organizations published separate plumbing and mechanical codes. The International Code Council, or ICC, published the first International Plumbing Code, or IPC, in 1997 and International Mechanical Code in 1998. Model codes specify in great detail how a plumbing or mechanical system should be designed. Plumbing codes specify the number of sanitary fixtures required based on the type of occupancy. And there are charts there in IBC that you can refer to. Sound ratings. Model building codes sometimes require the use of insulation to control sound transmission in wall and floor assemblies, separating dwelling units or guest rooms in residential occupancies from one another and from public spaces. Codes usually specify the minimum sound transmission class, or STC, for walls, or impact insulation class, or IIC, for floors. Construction details can then be designed to satisfy these requirements. All right, so let's move to the barrier-free design and ADA requirements. And this is a large and very important part. So let's try to go over it. So there are a lot of graphics in the book, so please refer to them because it may sound a little difficult, but when you back up the video with the book, it will be really easy to understand. So the two most recent pieces of legislation dealing with accessible design are the Americans with Disabilities Act, or ADA, which is a federal civil law, and the Fair Housing Amendments Act. So it is not a building code, it's a civil law. The latter expands the non-discrimination protection of the Fair Housing Act to persons with disabilities as well as persons with families. The main purpose of ADA legislation is to make American society more accessible to persons with disabilities. With few exceptions, all existing buildings as well as new construction must comply with the American with Disabilities Act. While the employment positions of the ADA apply to employers of 15 employees or more, it is public accommodation provisions apply to all sizes of business, regardless of number of employees. State and local governments are covered regarding of size. The ADA consists of 5 titles. Title I, Employment. Business must provide reasonable accommodations to protect the rights of individuals with disabilities in all aspects of employment. Title II, Public Services. The regulations of Title II apply to public services provided by state and local governments and include public school districts, the National Railroad Passenger Corporation, port authorities, and other government units. Title III, Public Accommodation. This segment of the law applies mainly to commercial facilities and prohibits privately owned and operated businesses from denying goods, programs, or services to persons with disabilities. Title IV, Telecommunications. This section is aimed at federally regulated telecommunications companies and federally funded public service television offering services to the general public. Type 4, Miscellaneous. This section includes a provision prohibiting coercion, threatening, or retaliation against the disabled or those attempting to aid people with disabilities in the assertion of their rights under the ADA. So let's take a look at the relevant ADA components. Accessibility guidelines. The site surrounding the facility should be surveyed during the review for handicap accessibility and pedestrian and vehicular circulation, and layout should be reviewed for unimpeded access to the entrance of the facility. Likewise, the accessibility of the parking area, including the adequacy of location, dimensions, and identification of parking stalls, should be reviewed and recorded. Walkways should provide adequate access between various side areas and the building. The walkways should not be less than 48 inches wide and should not have a slope in excess of 5%. So it's 1 foot rise in 20 feet. Accessibility is achieved by addressing the requirements of the ADA and other applicable codes, as well as state and local regulations. These are essentially three accessibility documents that designers and consultants most frequently use and should be familiar with. ANSI A117.1 was developed by the American National Standards and Institute, or ANSI, and is one of the first accessibility guidelines to be used in the United States. The latest editions of ANSI A117.1/ICC is the 1998 edition, which was developed jointly by the ICC and the Access Board. The Americans with Disabilities Act Accessibility Guidelines, or ADAG, was developed by the Architectural and Transportation Barriers Compliance Board, or ATBCB, or Access Board, as a guideline for ADA legislation. It was based on the 1986 ANSI 1 A117.1, but after the incorporation of additional requirements, it became stricter than ANSI. The Uniform Federal Accessibility Standards, or UFAS, are based on the 1980 ANSI standards and applies mostly to government buildings and organizations that accept federal funding. Accessible routes. The ADA defines an accessible route with a continuous, unobstructed path connecting all accessible elements and spaces in a building or facility. This includes pathways, corridors, doorways, floors, ramps, elevators, and clear floor spaces at fixtures. Adequate corridor width is essential to passage for someone with mobility or vision impairment. The ADAG puts great emphasis on the provisions for access and egress and clearly delineates the requirements for length, space, lighting, signage, and safety measures. Corridors, for example, should ideally be a minimum of 42 inches or 1065 millimeters wide and not more than 75 feet long or 22.9 meters. They should be well lit with indirect lighting to prevent glare. Wall finishes should incorporate blends of contrasting colors to increase visual acuity. Openings that form part of an accessible route should not be less than 32 inches or 815 millimeters. The minimum passage with two wheelchairs is 60 inches or 1,525 millimeters. If an accessible route is less than 60 inches or 1,525 millimeters wide, passing spaces at least 60 inches by 60 inches must be provided at intervals not to exceed 200 feet or 61 meters. The ADAG stipulates that the minimum clear floor space required to accommodate one stationary wheelchair is 30 by 48 inches. For maneuverability, a minimum 60-inch diameter circle is required for a wheelchair to make one 800-degree turn. In place of this, T-shaped square may be provided. Doors and doorways. Doors should have a clear opening width of between 32 and 36 inches when the door is open 90 degrees. The maximum depth of a 32-inch wide doorway is 24 inches. If the depth exceeds that, the width must be increased to 36 inches. Threshold heights should not exceed ½ inch and should not contain any sharp slopes or abrupt changes, but should be beveled so no slope of the threshold is greater than 1:2 ratio. Door closers should not hamper a door's use by the disabled. No part of an accessible route may have a slope more than 1 to 20, and that's 1 inch rise for every 20 inches of the distance. If a slope is greater than that, it is classified as a ramp and must meet different requirements, including the handrail provision. Barrier-free codes also require that door hardware meets standard specifications. Lever handles on doors for disabled people are usually cost-effective. All hardware on doors, cabinets, and windows should be easy to grab and operate with one hand and should not need a uh, a tight grip for turning. That includes lever-operated push-type mechanism and U-shaped handles. Standard doorknobs are not allowed. Plumbing fixtures and public lavatories. If a toilet stall approach is from the latch side of the stall door, clearance between the door size and the stall of any obstruction may be reduced to a minimum of 42 inches. Many toilet stalls are positioned at the end of the path of travel between the row of stalls and the wall. The advantage of using an end toilet for the accessible stall is that the grab bars can be fixed on the wall rather than a partition, which allows sturdier anchoring to meet minimum strength requirements. So there are a few requirements associated with the toilet stall layouts, and let's take a look at them. So toilet rooms as well as toilet stalls must have a minimum 60-inch clear internal turn-in space. However, a clear floor space at fixtures and controls may extend up to 19 inches under a wall-mounted sink. The clearance depth varies depending on whether a wall-hung or floor-mounted water closet is used. In most cases, the door must provide a minimum clear opening of 32 inches must swing out away from the stall enclosure. If a stall is less than 60 inches, toe clearance is required under partitions. In plain toilet rooms, a 5-foot diameter clear space should be allowed for. And let's go over this list real quick. So, stairs and ramps. Ramps should be installed as needed in areas of pedestrian access level changes. They are required to provide a smooth transition between changes in elevation for both wheelchair-bound persons as well as those whose mobility is otherwise restricted. Otherwise, the designers should use the least possible slope, but in no case should the ramp have a slope greater than 1 to 12. The maximum rise for any ramp is typically limited to 30 inches, after which a level landing is required. A slope of up to 1 to 8 is permitted if the maximum rise does not exceed 3 inches. In all cases, a non-skid surface should be in place to enable traction in inclement weather. The ramp's clear width must not be less than 36 inches, with landings that are at least as wide as the widest segment of the ramp leading to them. Landing length must not be less than 60 inches, and if ramp changes direction of a landing, the landing must be at least 60 inches square. Handrails on both sides of ramps are to be incorporated if the ramps have a rise greater than 6 inches or a length exceeding 72 inches. The top of handrail should be from 34 to 38 inches above the ramp surface. Handrails must extend at least 12 inches beyond the top and bottom of the ramp segment and have a diameter of or width of gripping surface from 1.5 to 1 and 3/4, excuse me, to 1.5 inches for both ramps and stairs. Floor surfaces and tactile pavings. Floor finishes in a facility must be firm and slip resistant and should provide easy access throughout the building. If there is a change in level, the transition must meet the following requirements. If the change is less than 1/4 of an inch, it may be vertical and without edge treatment. If the change in level is between 1/4 inch and 1/2 inch, it must be beveled and its slope no greater than 1 to 2. Changes greater than 1/2 inch change in classification to a ramp, which must meet the requirements outlined in the previous section. Bathroom doors should have a non-slip finish. Door handles must also have a textured surface if they are part of a door that leads to an area that might prove dangerous situation to a blind person, including doors to loading platforms, boiler rooms, and stages. Public telephones. Telephones are one of the easiest building elements to make accessible, so they should be positioned so that can be reached by a person in a wheelchair. Accessible telephones may be designed for either front or side access, and just in case the clear space is no less than 30 inches by 48 inches. This is a little outdated just because we all have cell phones, but still the requirement is still there. So if there is a public telephone, the 30 by 48 inch space should be provided. The next one is protruding objects. So these are restrictions on objects and building systems that project into corridors and other walkways because they present a hazard for visually impaired people. There are no restrictions on protruding objects that um, at lower age is less than 27 inches above the floor because these can be detected by a person using a cane. However, protruding objects cannot reduce the clear width required for an accessible route or maneuvering space, and a guardrail or other barrier must be provided for areas adjacent to accessible routes where the vertical clearance is reduced to less than 80 inches. Signage and alarms. Signage should give clear guidance for visually impaired people to emergency information and general circulation directions. Of importance in evaluating signage criteria is the ability to be viewed by people with low vision, 20% of normal from a distance of 30 feet. Signage is also required for elevators and handicapped accessible entries or sites, toilets, and other locations. For optimum clarity, adequate luminescence should be provided. The ANSI standards specify the width to height ratio of letters on how thick the individual letter strokes must be. And please refer to the graphics. It's really good to know and to see actually how it looks in the field. So the ANSI uh, width to height ratio of letters is actually the characters, symbols, pictographs, or other signs should be raised 1/32 of an inch. If accessible facilities are defined, the international symbol of accessibility must be used. Braille characters must be grade 2. The ADA accessibility guidelines state that if emergency warning systems are provided, they will include both audible alarms and visual alarms, complying with 428 audible alarms. They must produce a sound that exceeds the prevalent sound level in the room or space by at least 15 decibels. Visual alarms must be flashing lights and have a flashing frequency of about 1 cycle per second. And then the final one is elevators and elevator cars. So all elevators must be accessible from the entry route, and all public floors and must comply with applicable codes for elevators and escalators. Elevators must be provided with handrails fixed 32 inches above the floor on all 3 sides of the cab. Minimum cab size should be 67 inches to allow a wheelchair to maneuver. Both visual and audible hall signals are important to inform elevator passengers where an elevator is and in which direction it is going. It is particularly important that an elevator banks comprising more than one car. Elevator controls should comply with ANSI A117.1 standards regarding visual, tactile, and audible controls. And this actually wraps up chapter 11. I will see you in chapter 12. Thank you so much.